Alright, so we looked at the using the substitution for indefinite integrals. Okay, so we've got all the steps we needed. However, there's a couple extra things we need to do when we have a definite integral, but the steps are more or less the same with an extra step you need to do. Alright, so we do the substitution. So du is going to be 2x dx. Okay, so I'm observing what I've got. I've got 2x dx, so I'm done there. Right, I know what I've got for x squared take away 1 from the substitution. So it's going to become the square root of u du when I integrate. However, because I've changed my variables from x's to u, I also need to change my limits of integration from x to u's. Okay, that's the only extra step you need to do. So, suggestion how I'm going to do that. Well, x's to u's. What have I got there that I can use to change x's to, x's to u? Substitution. Okay, these are x equals, so if I substitute that, I'm going to get u equals. Okay, so x is 2, u is going to be 2 squared take away 1, so 4 take away 1 is 3. Right, x is 1, u is going to be 1 squared take away 1, which is 0. Right, and that's the extra step, just changing those bounds of integration. Right, so the integrand become the 3 to 0, my new limits of integration of u's. The x squared take away 1 gets replaced with the u, and I've already got the straight substitution for 2x dx. So it'll be u square root of u du. Alright, so we equal 2 square root of u cubed over 3 from 3 to 0. Right, so this one I don't have to write back in terms of x because when I do a substitution I'm going to get a constant number, aren't I? Right, so that's one thing you don't have to do. Right. So it'll be 2/3 20 square root of 27 take away 0. Square root of 27 is going to be 3 root 3. So 3 root 3 times 2 over 3. That's going to be 2 root 3. Okay, now this is not asking for area, it's just asking you to find the definite integral. Okay, so you don't need to have area, you don't need to consider absolute values, etc., etc. You are just doing straight integration here. When it asks you to do area, you might need to do more. Alright, well you will in terms of writing unit, but in terms of your answer as well. The other reason is, if you remember how I told you if it crosses your axis of integration, you're going to have difference of area. Okay, you don't need to worry about that in this case, only when it's asking you to find area or volume or light. Right. Use the substitution of x equals tan of theta for that integration. Okay. So when you differentiate tan, you get what?
6.
Okay. It is on your reference sheet somewhere. Okay. So I've got dx just on top, so I can replace that with that. I know I can replace x with tan theta. Okay, and I need to change the bounds of integration, alright, because they're x's. So x equals 1, 1 is tan of theta. The tan of what angle makes 1? 45, okay. So theta is pi and 4. Right, x is 0. 0 is going to be tan of theta. Tan of what angle makes 0? 90 is the asymptote.
0.
Just your third quadrant here, so we'll be fine. Okay, so the integrand, so I'll replace 1s and 0s with what I've just made the substitutions for over there. Okay, dx gets replaced by sec squared, and 1 plus x squared becomes a 1 plus tan squared on the bottom. So it becomes the integral of pi on 4 to 0. Dx gets replaced with sec squared theta over 1 plus tan squared theta with respect to theta. Hey?
Don't like this.
You don't like this?
Don't like this.
Well, can I integrate that?
Yeah.
Well, yeah, you can, but what do you need to do first? What do you mean make them all the same?
Peter, that's it.
Something should be jumping out at you straight right now. Like, really. Pardon? We've already made the substitution, but we don't need to make the t substitution, no. One plus tan squared is 1 with the tan is sexy. So integral of pi on 4 to 0 of sec squared theta over sec squared theta. What looks really difficult actually now becomes very easy because all you're doing is integrating 1 with respect to the theta. Okay, so theta from pi on 4 to 0. This is why we can't just write 45 degrees and 0, because sometimes you've just got nothing to substitute it other than an arc length. Okay? Right, so don't muck around with your formal setting out when it's obvious it's going to be pi on 4. Okay? Now, one of the last things we are going to do is we're going to look at more examples of this in integration. Alright? Not today, but down the track. Alright, next one. From 3 to 1 of 2 take away 2x all over the square root of 2x take away x squared using these substitutions. Remember, they will tell you the substitution in extension 1. Alright, but if you just look at it, if they didn't tell you the substitution, it will become very obvious once you do a few what you would make the substitution to be. Okay, and that's one of the skills you will need for extension 2. Okay, so I'll start with that. So du is going to be 2 take away 2x dx. Right, and I've got the numerator ready. The 2 take away 2x dx, I'll just replace with du. That's great, don't need to do anything else with that. I've got 2x take away x squared, just replace with the square root of u. But the other thing I need to do is that. Alright, don't forget to do those. So when x is 3, u is going to be 2 lots of 3, take away 3 squared, so negative 3. 6 take away 9, negative 3. And when x is 1, u is going to be 2 take away 1, which is 1. Okay, even though 1 is higher than -3, and that will be the bottom of my integrand, okay, you need to leave them as they are. You can't just swap them. Yeah. So the integrand become the limits from -3 to 1. So 2 take away 2x dx on top, so I'm just replacing that with du. And then the square root of 2x take away x squared using my substitution becomes the square root of u. So this is, when you say du over something, it is 1 over whatever that something is in terms with respect to du. Okay? Alright, so it's 1 over, so it's going to be u to the negative half. Alright, if you use your index clause there, so it'll be 2 root u from -3 to 1. Ooh, we have a problem.
Oh, it's a complex number. I don't wanna.
Complex numbers are not in extension 1.
We just leave it like that and we're happy with that.
Unless I made an error with what I wrote the question down to, we can't actually do that. I got that bit right, didn't I? X is 3, U is 2, lots of 3, take away 3.
3 squared is going to become positive.
Sorry?
3 squared is going to become positive.
No, because you're taking away 3 squared. You don't have a -3 all squared.
Take away 9.
Is it,
Yeah, so 6 take away 9.
is it, it's a negative u. It's a negative square root.
That's going to make another
It's still going to be the same thing.
2 take away 2x, that's fine. Square root of 2x take away x squared. So we can integrate, but we can't make the substitution because it won't be a valid point on your curve. Because if you think about your square root of u, the u y, square root of 2 root u, is that, isn't it? Right, and then I'm taking that bound from -3 to 1. Right, so mathematically there is no solution for that. Okay, so therefore, the square root of -3 does not exist in this course. You are doing nothing involving complex numbers in Mathematics Extension 1. Okay, so don't try and do something fancy in Extension 1 exams when you don't have the skills in Extension 1. Okay, so therefore no solution. Okay, possibly because I made an error in my writing down the question. Okay, but the main skills covered in terms of making the substitution, changing your endpoints of integration to match your new substitution, and go ahead and do the integration. Right. Hopefully the rest of them will be fine. Right, so from 1 to -1 of x outside of 3x, take away 1 to the power of 4. Okay, looking at that, it'll be trivial that the substitution is going to be 3x take away 1, isn't it? Okay, it'll come very obvious once you do a few. Right, so du is going to be 3 dx. So what do I have? I have x dx. So I've got a 3 dx. Right, so du over 3 is dx, and now I can replace that bit. Right, but with x, so 3, x is u plus 1, x is going to be u plus 1 all over 3. So that's what I'm going to replace with x. Right, so the other thing I need to do is my endpoint of integration. Everything's going to be returned to view now, so then I need to change those substitutions to be returned to view. So x is 1, u is going to be 3 lots of 1, which is 3, take away 1, which is 2, and x is negative 1, u is going to be negative 3, take away 1, negative 4. Right, and hopefully we won't have a problem with a negative number. I don't think we will. But we'll find out. Right, so the integrand become, so I'm looking at this, I've got x is u plus 1 all over 3, dx is du over 3, so I've got 3 times 3 on the denominator, so I'm going to move that right out the very front, because the 3 here and 3 here. Alright, so I'm just moving the factors out the front. Right, the rest of x is a u plus 1 and 3x plus 1, 3x take away 1 is u. du. Okay, and my bounds 2 to negative 4. Okay, so you might be looking at the 3 marks for this, okay? So your first mark, make the correct substitution, second mark for the correct integration, and third mark for your correct answer. Alright, so 1 over 9, the integral from 2 to negative 4 of u to the power of 5 plus u to the power of 4. Respect to d. Right, so I've just done the expansion to set it up. Right, so u to 6 over 6 plus u to 5 over 5. Right, and I have no square root, so I'm going to have no problem with substitution there. Okay, so don't forget when you're taking away for your second point, you need to have a bracket because there's more than one term. Alright, and don't forget the u is negative 4, so that part of it needs to be in a bracket because you are substituting the value for u. In this case it's negative 4. Alright, work it out. Okay, so we're both getting what's going on, how to do this. Alright, once you practice a few, they'll become very simple.
Yes. Negative 96.7111111.
Look at the fraction. Fraction.
Negative 4,352 over 45.
4, 3.
52 over 45.
Okay, so remember this was an area question. You first need to consider if there's parts of it above and below by considering the graph, alright, which we'll look at in the future as well. Alright, but if you just straight integration, that is all you need to do. Alright, any questions so far? There's 2 more, so we can stop now and do the 2 next lesson and continue on theory, or we get the 2 done now. Had enough?